So in your textbook, there is one analysis which is losses and risks. I think this is a good discussion. At the end, we, based on the probability, we take an action, right? So what could be the action? For example, let's say we want to advertise a computer. Okay? So if we think that this person is not likely to buy, we are going to skip. Okay? But what could happen is this person might be still interested in buying a computer. That's a wrong prediction. And this person might buy the computer from another store. And we lose the customer. Okay? And there are several things to consider. First, this person did not buy the computer from us. We have the store. We lost value on it. Okay, that's the minimal loss. You can look at it. And another thing that happened is this person learned about another store and then may start buying the items from that store, right? So that is the long-term loss for us. So we might be losing this customer for a long time. Okay? So there is a significant risk involved if you classify as a no, this person buys the yes. Okay. So this idea here, okay, tries to, it's just a formula, basic formula representing the risk, okay, of making a decision or taking an action. So this is alpha I is an action you take, and based on that, okay, we had the probability, you have lambda ik. Lambda ik is the, you can assume that it is the risk coefficient. The idea is you need to pick among all those actions. Okay, this is what it says. Pick the one, pick the action that will minimize your risk. Okay? But sometimes it's possible that don't think that we should, pick one thing significantly. There is nothing. You need to think about the probabilities. It's possible that if you have multiple classes, one of them could be just 0.00001. Okay. So it doesn't mean that you need to take an action against that one, because your risk could be very little. There are, 1 million people, only one person, could buy the computer. Maybe you don't have a risk because you have lots of investment, right, to attract that customer. Maybe that's not a big risk over there because you need to do significant investment over there. 0-1 loss, okay. 0-1 loss is simple. So if you make the correct decision, your risk is actually 0. So I is equal to k. The correct class is k, and you take the action alpha I. Okay, you take the ith action, correct class. So you have the correct action for the correct class. So the loss is 0. But in the other case, if you take any other class, then this coefficient will be 1. So it's a wrong decision. So if you put this in this way, for each wrong decision, okay, you need to multiply with this lambda. Lambda becomes only 1 when the classes are different, okay? If you don't have lambda, okay, if you just ignore this, this is the probability of each class, right, from 1 through k. So the sum of probabilities must be 1, right? You remember? The sum of the probabilities must be 1. What is the probability of x being belonging to class 1, class 2, class 2? If you add them up, you get 1 normally. So you add everything except the class itself, right? So you have a value, you add class C1, C2, C3. Whenever I is equal to k, you skip it. So it's actually 1 minus probability of x given Ci. So you subtract that correct class's probability, and then you get the risk factor. Okay? That's one view. This is how you can measure it. And another way to look at it, this is one more step involved here. I don't know if it's a good representation or not. We add one more class or one more action. Okay, action is not one of the classes we have. So we think that, okay, we have k cases. Well, I cannot decide. The system cannot decide. So we decide to reject to make a decision. Okay. So we say that, okay, at this time, what does the action means? ask an expert. Does this person have a cancer? Don't let the computer decide it. Okay. Call an expert and let the expert make that decision. So A+1 means the system will reject to make a decision. It is not sure, basically. Okay. And we can label that has a cost lambda. Okay. So we already put 1 if the classes don't match. Okay. The cost, we have a probability of that cost. And if we do that now, we have now consider the cost of rejecting. Okay, this is the risk of rejecting a decision. So again, we have everything. K is equal to 1 through k. In this case, we have lambda. Okay, why is it lambda times probability? Why do we get lambda here? Because you know that summation, we don't pick any action relevant to that class. If it is in class 1, we say do this. If it is class 2, do that, right? So we have corresponding actions. But we don't pick any of them. So it means that you are adding all probabilities. You are multiplying with lambda. It means that you are just going to get lambda at the end. Okay, this is the risk. Now, if you remember, so this is where it comes into picture now. So far I have shown that how do we pick class CI versus class CK? We compare its probabilities, right? So if the probability of CI is greater than CK, then we pick CI. But if the risk is critical now, we may consider rejecting. Okay, so we also need to make sure that we have a cost of rejecting lambda. This probability should be greater than 1 minus lambda. If both cases are satisfied, then we pick plus CI. Okay, otherwise we reject. So we add one more condition here. If this is true, so because this is a cost of making incorrect decision, you can look at it that way. So if this is greater than 1 minus lambda, we pick it up. Otherwise, we say that, okay, it's better if we talk to an expert and make the decision. What is the problem in this case? Okay, it's a good idea. This works fine. But the question becomes, what is a good lambda? Okay? So that is not part of the answer. So you should consult to an external person to come up with a good lambda. So what you need to know here, as a summary of this slide, we may also consider rejecting to make a decision. Okay, so rejecting has a cost lambda. So whenever we pick up a class I, in addition to we compare the classes, we also need to compare with 1 minus lambda. Okay, that is the summary of this slide. So we need to include that type of risk or losses in some scenarios.